So let's start off our day number 6 review with looking at the free response that you did related to Chapter 2, which was yesterday. What I want to highlight here is a few things. When you did look at the scoring rubric, one thing you need to make sure that you're going to have two different box plots here. You must have them labeled additive A and additive B, and it doesn't matter which one you put on the top or the bottom. Also, you must do the outlier test. They said here showing outliers. So if you do the outlier test, you can check the outliers. My recommendation is this. I would have loved to have all of the raw data here, which we don't have all of the raw data, because you can tell that it says additive A was randomly assigned to 15 of the cars. This data here is not all 15 pieces of data. If it were, what I could do is put the data in my calculator and just have it make a modified box plot for me. Unfortunately, I don't have all 15 pieces of data. So you do have to do the outlier tests on this first, a very important concept because they tell you specifically to look for the outliers. Now, part B of this question here, they really want you to look at the box plots. And the thing to keep in mind about the box plots, you guys, is that remember how the data is chunked off. So talking smartly on a box plot, what we know is 25% of the data is here, 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 and here. So when you look at the scoring rubric, they're going to talk about that you could say at least 75% of the cars with additive A. Well, where do you see all 75? You could tally this up, and that's 75% of the cars. So talk smartly about it and look for the things that really look unique in these two box plots. And if you haven't, again, graded these yet, you need to go ahead. I'm not going to reiterate what the scoring rubric says. They're short answers. Look at the AP Board's responses to question part 1 and part 2 and make sure you understand that. That then brings us into day 6 review. It is the last day on topic 1 of exploring data. We wrapped that topic up with bivariate data. Making scatter plots, so things with ordered pairs of X's and Y's. Here were the various learning objectives. From here, we are going to have to get some standard vocabulary that you're going to need to know how to recite very easily. So let's review those key concepts. Already addressed this as making a scatter plot. Remember, the explanatory variable is kind of our input, our X value. The response is the Y value on that one. When they ask you to explain or describe the scatter plot, because it's bivariate data or two sets of data, this is where we talk about our DOFs. Don't forget your DOFs on this one. That is direction, form, strength, and any obvious outliers. There is not an outlier test for bivariate data, so this is just going to be if you see anything very standoutish that you need to talk about, something that departs from the pattern. In terms of associations, our direction would be positive or negative. The form could be linear or curved, and the strength could be weak or moderately weak or strong. One of the things when they talk about correlation, the correlation is the strength and the direction. So we know in the calculator or the computer output, correlation is going to be defined by the letter R. And again, gives you strength and direction. So you have to say positive or negative and how strong it is. The correlation goes from -1 to 1. -1 is great, so is +1. 0 is very bad linear correlation. Also, R is just for linear correlation. It's not for other types of shapes. This bullet point here, this last one, is important to talk about for correlation, is that the value of R is not affected if you were to change the explanatory and response variables around. So if you flip-flopped X and Y or you found your inverse, the R is still going to be the same value. The correlation is also not resistant to outliers, so that means it's impacted greatly if there's an outlier in the data set. Your correlation will be adjusted probably where it shouldn't be. Section 3 then talked about writing the equation for the regression line. Remember, when we write this equation, we have to put your hat above your Y. The Y is our response variable, X is our explanatory. B here is the slope, A is our y-intercept in this case. We can make a prediction from here, but your prediction answer is going to be y hat, so don't forget that. We had extrapolation. If our data set, let's say they gave us the ordered pairs and the x values of the ordered pairs range from 1 to 5. If they asked us to predict something when x is 10, that's extrapolation. We're outside of the data, so it may not give us a valid answer. The least squares regression line is the equation that the calculator gives us when we do a linear regression. Also reference your formula sheet. If they want the equation of the least squares regression line and they give you the values, for example, the standard deviations and correlations and the means, you can compute it. What we have here, again, is this is the format for the equation. We can find the b value or the slope mathematically. We just need the correlation and we times it by the standard deviation of y over standard deviation of x. This is on the formula sheet. The a value is our y-intercept. We can find that by the mean of y minus the b value we just found here times the mean of x. Residuals are a good vocab word to understand. It is observed minus predicted, so it is alphabetical. The observation is the data that is given in our table. So the observation is what was the response that we collected. If I went and I asked people, how many dogs do you have at your house? That might be X. And then I might ask them how much they spend on pet food a year. So someone might have 3 dogs and spend $100 on pet food. Our number of dogs is explanatory. Our response is the amount they spend on pet food. So our observed would be on this one how much we actually spent on pet food. Our predicted we would get from the equation that we get. If your residual is a negative answer, means your predicted value is higher than your observed value. So that means that your prediction, the observed value, is below your line of best fit. If the residual is a positive value, it means your observed value is larger than your predicted. So your observed value is actually the scatter plot itself, and it means the scatter plot dot is above your line of best fit, which is your prediction. We could also look at residual plots. Remember, in residual plots, it's just plotting for all of our x values, the observed minus predicted. When we look at this residual plot, we don't want to see curvature in it. We want to see just random dots kind of all over the place. Vocab worth knowing right here is the standard deviation of the residuals. It's on average the size of the prediction errors when we use a regression line. So how much will we be off in our prediction if we actually use a regression line? Coefficient of determination is one I have seen the AP board ask you to write out in more of a sentence structure. You really want to know this definition. It is the percent of variation in one variable that is accounted for by the least squares of regression line on the other variable. And you have to put that in context. So again, look back in your notes. Look what we have for examples for coefficient of determination. If they give us r, we can easily find coefficient of determination. You just square r. If they give you r squared or coefficient of determination, you can actually find the correlation fairly easily. Take the square root of r squared, but then you have to look at the slope to see if that should be positive or negative, because correlation actually takes into consideration just not strength, but also direction. Another point here is outliers. Outliers do have an impact on correlation. The outliers that are more in the x direction, so if we were to look at some graph paper and we looked at the x-axis here and the y-axis here, if we had outliers deviating way over on this far side more on the x direction over here versus on the y direction if they were higher outliers, the ones on the x are more influential on the actual correlation than the ones on the y. These are called influential points versus if we had an outlier in the direction of the y, which might sit up a little higher here, is not going to be as influential even though it may look like an outlier. A few of the last points. Remember that cause and effect relationships between two variables can't be made unless we have an experiment that's been imposed, which comes more into Chapter 4. But just because you see a strong association doesn't mean there's a cause and effect. When you're asked if a linear model is appropriate, the first thing you want to look at is the actual scatter plot. And then look at the correlation. Do you see, is it positive or negative? What's the strength? How close is it to 1 or negative 1? Lastly, look at your residual plot. You're looking for null pattern and make a decision. It is very important, though. I have seen them try to trick you on various multiple choice questions at times because you haven't seen a scatter plot, so you might need to have more information.